So we're at what we call the VEC, the Vertical Energy Centre, and the significance of this facility is really it's just to try and accelerate and go through production and testing sooner. And so what we have here is we have engineering, we have the manufacturing, and we also have testing for predominantly our battery systems, but we also do a lot of other powertrain testing here, so power, LV components, high voltage components. The cell comes in, we take it through initial testing, all the way through manufacture, final testing, and then we hand it over to the aircraft for installation. We have this in-house facility so that we can go from design to test as quickly as possible. And it's much safer, and it's given us better performance. So the idea is to get the designers as close to the manufacturing as possible, and then be able to iterate through the testing as quickly as possible. So, we can build something one day, we can have it manufactured the next day, and then we can be testing it later that week. That just wouldn't be possible if we didn't have it all in one facility. And it's so much more robust. So we come across so many challenges, and when we need to find those challenges, the fact that we can go down and look at the manufacturing and then go back to the design again, we can do in a day what would have taken us weeks before. Essentially what we do is we generate hours and hours of replicating what the cell is going to see in life. We replicate with temperature, humidity, and the electrical performance. So the reason why we do all of this testing is because we have to ensure that the aircraft is safe and that our products are safe and what we're handing over to the aircraft for flight test is safe. A battery system is broken down into 8 identical systems called subpacks. So subpack level testing, we've done 1,185 hours. We've done more than 1,500 hours at subpack electrical cycling for aircraft 2, but that's on the entire system. So we have tens of thousands of hours at module level, we have millions of hours at cell level, and so we kind of build that up from simpler testing at cell all the way through to higher level sort of testing. And mechanical will involve vibration testing, shock testing. Our partnership with Molicel is very important because right at the center of any battery is the cell. And it's the one part that we don't do in-house. And so it's very important, considering the entire performance of the vehicle is dependent on it, that we understand what the cell is capable of and that we have a supplier that we can trust that can provide the quality that we need and the volumes that we need and hit the other performance aspects. We can build batteries. Certainly in this facility we can build batteries, and that's important for us to be able to do the initial part of the design. We can enter into service with what we have here, and so predominantly what we focused on is we focused on a facility that allows us to be able to scale up very quickly. So we use industrial processes, we use equipment and facilities that are used at rate in places like automotive that allow us to be able to take what we've got here and scale it up into a much larger facility with a higher throughput much quicker. It's just a very interesting technology. So the challenges, the fact that no one's done them before, which gives you a lot of freedom to be able to come up with a solution. It's a cool job.